Vertical heights can sometimes be measured using either the angle of elevation or the angle of depression. Okay. And so if a person is looking up at an object, okay, this acute angle here, measured from the horizontal line of sight to the object, is called the angle of elevation. Okay. In the same way, if a person is looking down at an object, the acute angle made by the line of sight to the object and the horizontal is called the angle of depression. Okay, so sometimes you'll hear those terms used, angle of elevation and angle of depression. Okay, um, so let's look at a couple examples involving this. Okay, meteorologists find the height of a cloud using an instrument called a ceilometer, and it consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. So we have at the Chicago airport, a ceilometer was employed to find the height of the cloud cover. So it's set up with its light detector 300 feet from its light projector. Okay. Um, and the angle of elevation from the light detector to the base of the cloud was 75 degrees. And so we want to know what was the height of the cloud cover. Okay. So we know it's helpful. We're given a diagram here, but if you don't have a diagram, it's helpful to draw one. So we know this distance here between the projector and the detector is 300 feet. And we know the angle theta is 75 degrees. Okay, and we're looking for the height h. And so we have, we're dealing with, again, we're dealing with the adjacent side, okay, and the opposite side. So you have to ask yourself what trig function deals with adjacent and opposite, and that's going to be tangent. So we know that tangent of 75 degrees must be equal to the opposite, which is h, over the adjacent, which is 300. And now we can solve this for h. We'll multiply both sides by 300. And we'll get that 300 times tangent of 75 degrees is equal to, so that's h, and that comes out to about 1120 feet. Okay. So the height to the base of the cloud cover was approximately 1128 feet. Sorry, 1120 feet. All right, and that would be the angle of elevation there. Okay, so we have a statue placed on top of the Board of Trade building in Chicago. And from street level, we take two observations, 400 feet from the center of the building. Okay, so the angle of elevation to the base of the statue is 55.1 degrees, and the angle of elevation to the top of the statue is 56.5 degrees. And so we want to be able to find what the height of the statue is from that. Okay, so what we have is really two different triangles here, and I'll draw them separately, right? So we've got one triangle. I won't draw them quite the same size, but right, we've got one triangle that has an angle of 55.1 degrees. And this base here is 400 feet. Okay. And we'll call that height B. And then we have the other triangle, right, measuring to the uh, top of the statue there. And again, that's still a base of 400 feet. Okay, but that angle is slightly different. It's 56.5 degrees. And I'll call this point B prime. So the height of the statue is going to be the difference between these two values, B and B prime. Okay, so the height of the statue is going to be the difference between B prime and B. Okay. So now we can just use trigonometry to figure out both of those. So let's take the first triangle here. Okay, and again, that B is the opposite side, right? This is the opposite side, and this is the adjacent side. So we know that the tangent of 55.1 degrees is equal to the opposite B over the adjacent, which is 400. Okay, and then we'll multiply that both sides by 400. Okay, so we get that B is equal to 400 times the tangent of 55.1, which is going to come out to approximately 573.39 feet. And then similarly, we'll find B prime, right? We can say that tangent of 56.5 degrees is equal to B prime over 400. Again, we'll multiply both sides by 400. So we have 400 times the tangent of 56.5 degrees, and that comes out to about 604.33 feet. Okay, and of course the height of the statue is just the difference in those two distances. So the height of the statue is going to be 604.33 minus 573.39, which is approximately 30.94 feet. Okay, and so we could call that, we would say approximately, we could call that 30. We rounded that, it'd be 31 feet.